This is question 11 from paper 1-3 from the Cambridge International Education Maths exam from June 2020. You can find a link to an image of this question in the description below this video, and I recommend trying it out before looking at the solution. This is the last question on this paper, and the questions do tend to get a little more difficult towards the end. But don't think too much of that. Still, always look at how many marks a question gives you. In this case, it's 11 marks. So that means how much harder it is. Earlier question might only give you 5 marks. So this is over twice as hard. But you get twice the reward. So don't worry too much about that. Now, in this question, they give us this cubic equation. So it's cubic because x to the power 3. And they tell us a lot of information about it. Well, they don't tell us that much. We're missing loads of things. B's. They tell us, though, that this is a maximum. They probably should say local maximum. This is a local maximum here. They tell us this is a minimum. They probably should say local minimum, especially because they drew a little below it here. And they didn't draw above this, so technically is a maximum for this for what they've drawn. But anyway, that local maximum, local minimum tells us a lot of information. So what they actually ask us to do is show that b is equal to 3a. So if this is 1, this guy's 3. If this is 2, this guy is 6. They don't tell us what numbers are. We're not going to find out what the numbers are. They just want us to find out that b is equal to 3a. So how do you do that? We use all the information they give us. And one of the pieces of information is the local maximum and minimum. And what you should be thinking when you think that, you should be thinking the derivative. So dy dx. Here's y. We can find dy dx. So let's find it. We get 3x squared. B is just a constant, so we'll get minus 2b multiplied by 2, I guess. Well, let's do this all in one. Minus 4b x plus b squared. There's a 1 above the x. 1 multiplied by b squared is b squared. X to the power 0 is just 1. Okay, so this is the derivative. Now we know what point is here. We know this is the point a something. In fact, we're going to actually need this y part later on in the question. So we know what goes in here. We know what number. This is x. When x equals a, this is going to equal 0 because we know it's a maximum. So let's just put a in. We get 3a squared minus 4ba plus b squared equals 0. And that's all we need now at this point. Because we have an equation, there's 2 things in it, a and b, and what we're looking for is an equation with 2 things in it, a and b. So if we play around with this a little bit, and it's tricky enough, but we can actually factorize this. If we factorize it, we get 2 things that multiply to get 3a squared. 3a and a will do it. 2 things that multiply to get b squared. B and b will do it. And hopefully this will work. We don't know it will yet, but hopefully this will work out. So let's see. If b multiplied by a and b multiplied by 3a, does that make minus ab? Minus 4ab? It does if this is a minus and this is a minus. We'll get, let's see, we'll get minus 3ab minus another ab is minus 4ab. This all works. This is the same as this. That means I can solve it. I can say 3a is equal to b, or I can say a is equal to b. Now mathematically speaking, this could be the answer. A could equal b, but they gave us a picture. And in the picture, a definitely doesn't equal b. So we can go ahead and ignore that one. So that's our answer. That's what they were looking for. B is equal to 3a. Now you could have done this dy dx with x equals to b. You wouldn't have got anywhere. You would have just found out that 0 equals 0. That's a problem. You would have found out that one of the answers could be that b is equal to 0. And therefore a is equal to 0. And that's because a equals b. But again, none of that makes sense in the picture they gave us. B is definitely not 0. So this is the answer we were looking for. If you're looking for another way to do this question, because lots of students would panic being able to do this, first of all I would say you need to be able to do this. This is simple enough factorization in maths, but so many students, even A and B level students, have have never learned how to really do this properly, to get from this line to this line, I would recommend you put a bit more work into doing that. That's my first suggestion. But there is another way to do this question. You could also just get this line here, a 3x squared minus 4bx plus b squared equals 0. So they were asking you to show that b is equal to 3a. So what you could have done is just put, instead of b, put 3a, and instead of x, put a, because we know at a, this only works at a or at b. At a, this works. And if you put all that in, I think you'll get something like 5x squared minus 5a squared minus 5a squared, or something like that. Actually, you know what? You'll get 4a squared minus 4a squared equals 0. So that means when b equals 3a, yes, this is equal to 0. That would be another way to show it without doing the factorization. Anyway, that's the two ways to do it. Let's move on to part B. In part B, they ask us to show that the area of a shaded region, and that's this region here, is equal to k a to the power of 4, and where k is a fraction that we're meant to find. So basically, find the area of this, and they tell us the answer is going to look something like this. Just give us a clue on what the answer is going to look like. K is just a number. Maybe it's going to work out as a quarter or something like that. And again, they tell us it's going to be a fraction, which could be a little tricky because technically the number 2 is a fraction, 2 over 1. But I don't think they're trying to trick us there. Right, so how do we do this? To get the area under a curve, we need to start thinking integration. So to get the area under this curve here, we can do that. We can get that area all the way down to here. That's easy enough. Well, it's not that easy. It's integration though. We integrate y with respect to dx between these 2 points, which is 0. First point there is 0, and the second point is a. So that's it. That's how we integrate. That's how we can get the area of this. It's not going to be too easy, but that's what we can do. And then really all we'd be missing is this triangle. This triangle here, which is 0, a. So, well, this is 0, this is a. So the length is just a. We just need the height then. And remember I said earlier, we would need the height. We can find this height without much trouble. We just put a into this. So we get a cubed. Let me do that actually first. We get a cubed minus 2b. Instead of b, let's write 3a. So 2 3a, a squared plus 3a squared. That's instead of b squared times a. So this height, well, let's clean this up. 3a, a to the power of 3 minus 6a to the power of 3 plus 9a to the power of 3. Let's see, that's 10 minus 6 is 4a to the power of 3. So 4a to the power of 3. So that's actually easy to get the area of this. It's a half times this. Actually, let's just do the area of that now. A is equal to a half a 4a cubed, which is equal, a half times 4 is 2. A times a is a to the power of 4. Actually, that's good because they told us the answer would look like a to the power of 4. That's the area of this triangle here. Let's get the area of this guy. Let's do this integral here. So the integral of y, the integral of this big mess here, is, let's see, it's x to the power of 4 divided by 4. That's the integral of x cubed. Then it's minus 2b. Again, let's, instead of b, let's just replace b with a. You'll have to do it eventually. You don't have to do it right now. But 2 times 3a x squared. X squared becomes x cubed and divides by 3. Next term is b squared. Again, that's 9a squared, just like up here. And 9a squared times x to the power 2 divided by 2. Alright, 3 divided by 3, that's gone. Oh, all of this is evaluated between 0 and a. Right, let's add this all together. Let's put everything over 4. This is over 4. Let's put this guy over 4. We need to put in another 4. This guy over 4. We need to put in an extra 2. Right, this should be easier to do now. So we get x to the power 4 let's see, minus 8 x, oh yeah, so we have x cubed and an a, and then we have, let's see, 18 plus 18. I was thinking of the next step. I should have already put a in, maybe. A to the power of 3. That should be a to the power of 2. That's b squared is 3a squared, which is 9a squared. So it should be a squared, and then x squared, and all of this is over 4. And we still have to evaluate it between a and 0. I'm probably going to run out of room. Let's clear this off and we'll do it here. So to evaluate a equation at a 0, we just put a in for x, and then we put 0 in for x and take it away. So first let's put a in. We will get a to the power of 4 minus a times 3a, like a to the power of 4 again, minus 8, a to the power of 4. Again, a to the power of 4 here again. So that's plus 18 a to the power of 4. All this is divided by 4. And then look what happens when we put 0 in. We get 0, 0, and 0. So nothing happens. We don't have to put 0 in. So this is it. This is the area underneath here. This area here. And they all have 4s in them. So we can just add this together. We just get 18 minus 8 is 10. 10 plus another 1. This always has a 1 in front of it. Is 11. So 11 over 4, a to the power of 4. So what is the area, this wedge here? It's this whole area minus this one. It's 11 over 4, a to the power of 4, minus this one here, this triangle, minus 2, a to the power of 4. Instead of 2, let's write that as 8 over 4. Again, we're just making the fractions the same on the bottom row. 8 divided by 4 is 2. I didn't really change anything. So that becomes 3 over 4, a to the power of 4. We don't know that's right. I'm telling you it is. I looked up the answer. I confirmed that this is correct. But it is nice that they told us the answer would look like a to the power of 4 with a fraction. So it's a bit of a clue. We can actually feel happy when we get this. If you had got anything besides a to the power of 4, you know you're wrong. If you had got a number, that whole number here, that'd be messy. You'd probably guess you're wrong because they said fraction. Although, like I said, a whole number is a fraction as well. All right, that's it for this question. That's it for this paper. If you'd like to look at any of the other questions in this paper, check out the playlist. They'll be in the description below. I'll move on to the paper 2s next. I did all the paper 1s, paper 1-1, 1-2, and 1-3. I'll start doing the 2s, 2-1, 2-2, and 2-3. Check them out, subscribe to the channel, all that lark, and I'll see you next time. Have a good one.